I'll give you some example about the formulation of differential equation, that we are given an equation and we write differential equation of this one. We are given family of curve and we convert into differential equation. Take a first example. We are given the find a differential equation. Find differential equation for family of curve. Family of curves, and that is y equal to c1 cosine 2x plus c2 sine 2x. So this is, you can see it here, that we have two arbitrary constants c1 and c2. This means the differential equation we are going to formulate and we're going to get the differential equation must be of order 2. No, I just rewrite. I write the derivative of this one and then we simplify this one. Actually, we want to remove these constants c1 and c2. When we remove this one, eliminate this constant, the equation we're going to get the differential equation. So solution of this one, we take the first derivative, dy by dx is equal to c1, derivative of cosine is minus sine 2x, and derivative of 2x is 2. Plus c2, derivative of sine is cosine 2x into 2. So we simplify this one. We get here minus 2c1 sine 2x, and we get here plus 2c2 cosine 2x. Now we integrate, differentiate once again. I get here d2y by dx square. Again, take the derivative, we get minus 2c1, and we get here cosine 2x. Then derivative of 2x is 2, plus we get here 2c2. We take the derivative of cosine 2x, we get here sine 2x, and then derivative of 2x is 2. We rewrite this one. I can write this equal to minus 2 into 2 is minus 4, c1 cosine 2x. Then we're having it minus 2 into 2 minus 4, c2 sine 2x. So I just take a common from this, minus 4, and I'll get here this equal to c1 cosine 2x plus c2 sine 2x. We can see it here. If we look on the equation, then we're having here this c1 cosine 2x and c2 sine 2x here. This is my y. So I replace this one by y, and you can write here the result as that we get here d2y by dx square is equal to minus y. I substitute the y is c1 cosine 2x plus c2 sine 2x, and then I can just write the value of this one here. I get here 4 minus 4y. I take minus 4y to this side. I get here the differential equation is d2y by dx square plus 4y is equal to 0. So that's required differential equation for the family of curve, and differential equation is of order 2. Again, I repeat this one. We're having two arbitrary constants. We get the differential equation of order 2. So as in my last examples, you have seen that we are using the derivatives. And you must know the formula for the derivative. Very simply, we take here u as a function of x. And if I want to find the derivative of u to power 3, I get here d by dx. And this equal to 3u square into du by dx. So this is chain rule we're going to apply. For example, I have du by dx of sine u. So as I mentioned and used it, we get here cosine u into du by dx. So I can have here derivative of d by dx of e to power u. So then the derivative of this one is e to power u into du by dx. So you remember that we're having the differentiations, a formula like this one, d by dx of x to power 3. So that's 3x square is finished. But if we want to write the derivative of d by dx of y to power 3, so we say get here 3y square, and we get here dy by dx. We say use the chain rule, dx by dt. We're having here x cube plus y cube. So we use the derivative of each of them. We get here 3x square It's with respect to x, so it's only 3x square with respect to y, x with respect to y. We get a 3y square dy by dx. And similarly, if you have the product function d by dx, for example, I am having here x square, y square, then first function derivative second. First function x square, and derivative second function is 2y dy by dx. And then we are having here the second function, and derivative first, derivative function is 2x and y. This d by dx of xy, so we can have the solution of this one is first function derivative second, x dy by dx, and then here plus y into dx by dx is equal to 1. So actually this comes the implicit differentiation. This is the explicit differentiation function of explicit function is y is the function of x only. We have the function like fxy, they are implicit functions and equal to, say, for example. So we can solve this one with the implicit differentiation because we are going to use in the coming example the implicit differentiation, so you must master it. Also, this is very important for the course of the differential equation, that you must know the differential calculus, and in addition to that one, you must know very well the formulas and applications of the integral calculus, and especially the techniques of integration. If you are mastering that one, differential equation course is very easy for you. But if you don't know that one, that's become very difficult. The solution of this one is, we look on the equation family of curve by only one arbitrary constant. One arbitrary constant means, as I told you, we get the differential equation of order 1. So we have to differentiate only once, but we have to remove the constant. So here is y plus 1 whole square. We use the implicit differentiation. So derivative of this one, when we take, is equal to 2c1. We get here y plus 1. 2 minus 1 will be 1, and then derivative of this one is dy by dx, and the value of x is equal to 1. So here is constant c1, and we have to solve it. To solve this one, we just get the value of c1 from here and substitute in this equation. But the value of c1 will be equal to x over y plus 1 whole square. So I substitute the value of c1 here. I get here 2 into x over y plus 1 whole square into y plus 1 into dy by dx is equal to 1. We simplify this one. We can see it here that we can just cancel this y plus 1, which is 2, and we get here 2x over, so we can write here, we get here 2x over y plus 1 into dy by dx is equal to 1. We rewrite this one. Rewriting that one, we get here dy by dx is equal to, we get here y plus 1 over 2x, and this is our required differential equation for the family of curve, that is c1 y plus 1 whole square is equal to x. Dear students, you have seen that we are doing the examples and all that. If you don't understand something, you can just revise it and watch it again and review it again, and you will be able to understand that one. Actually, when in teaching we say this one-to-one teaching is the most powerful, and one can understand 100%. To me, using the videos and try to learn it is more powerful than that one, because in teaching you have the opportunity only to listen. It is not, one is not able to revise it, but here you can revise this one, and then when you understand it, go forward. When you want to check something which is not clear, you can again come to the video and you can check that one. So we solve this equation again. We want to formulate the differential equation of the family of curve. You can see it again that we are having only one arbitrary constant c1, and we want to eliminate it again because there is only one arbitrary constant. So differential equation is of order 1. So we take the derivative of both the sides. I can write here simply my dy by dx is equal to derivative of e to power minus x is e to power minus x, and derivative of minus x is minus, plus c1 e to power x. So that's the derivative. Again, what I need to replace this c1. So I calculate the value of c1 from here and substitute it here. I take this as c1 e to power x is equal to y minus e to power minus x. Then multiply e to minus or divide by e to minus x. I get c1 is equal to y minus e to power minus x over e to power x. So I want to replace this value c1 e to power x. So multiply both sides by e to power x. c1 is equal to y c1 into, we are having here e to power x is equal to y minus e to the power minus x over e to the power x into e to the power x. E to the power x is cancelled with e to the power x, and we get this y minus e to the power minus x. I substitute the value of c1 e to the power x in my differential equation, and I can rewrite it. I can get here the value of dy by dx. So my dy by dx is equal to e to the power minus e to the power minus x plus the value of c1 e to the power x, that is plus y minus e to the power minus x. So simplify this one, I get here dy by dx is equal to y minus e to the power minus 2 e to the power x. Take y to this side, we have the variable, that is y, we take on one side, and the variable independent of y to the other side. So that's my differential equation. I remove my arbitrary constant, only one arbitrary constant, my differential equation is of order 1. So I have this example, find the family of, find the differential equation of family of curve, y squared c1 e to the power c1 x cube. So again, we have only one arbitrary constant, that's c1. We take the derivative, and then we try to find c1, substitute the value of c1, we get our differential equation. So we start taking derivative of both the sides. I get here derivative of d by dx with respect to x, d by dx of y square. Then I take the d by dx of the right hand side, that's c1 x to the power 3, differentiating this one. Again, implicit differentiation, we get here 2y dy by dx, and we get here this equal to c1, derivative of x cube is 3x square. Again, the value, I want to find c1 and simplify this one. I come back this and try to find the value of c1 from here. So I get here c1 is equal to y square over x to the power 3. So the value I want to substitute here is c1 x square. So I write here c1 x square is equal to y square over x cube into x square. So that gives me here this equal to y square over x. So I substitute the value of this c1 x square in this equation, and we can rewrite this one. I get here 2y dy by dx is equal to 3. Now the value of c1 x square is equal to y square over x. Now we can take this value to the other side. We get here dy by dx is equal to 3 into y square over x, and the value from the left hand side is 1 upon 2y. So y is cancelled with y. I can write this equal to my dy by dx is equal to, after simplification, this is equal to 3y over 2x, and this is my required differential equation for the family of curve, which is y square is equal to c1 x to the power 3.